We're going to be working through a single replacement problem, breaking down the net redox reaction, oxidation half reaction, reduction half reaction, and oxidizing and reducing agent. So the first thing we need to start with is the actual two chemicals we'll be working with. So in this case, we're going to have solid zinc. And remember that as soon as you see a metal that is by itself not bonded to anything, it is going to be 99.9% of the time as a solid. And then I am going to have it react with AgNO3. Looking at my solubility chart, I see that anything bonded with nitrate will be soluble, so I place aqueous by this. All right, so let's create a drawing on this just to get a sense of what we see, because we know that silver nitrate is aqueous. For that reason, I know that the cations and anions have separated, so we have the cation of silver and the nitrate anion. Because zinc is by itself, it hasn't had another atom that it can actually give its electrons to. For that reason, zinc is going to have no charge. And what we're going to do next is we're going to see, is zinc strong enough to get what it wants in this fight and tug of war of silver and nitrate. So the first step we need to do is figure out what is zinc attracted to. So remember, zinc is a metal. Metals are cations. They have a positive charge. So in that case, it's going to be attracted to this negative charge, being the nitrate. So the thing we need to do next is we need to look at the activity series and see, is zinc stronger than silver to get that nitrate? And I look at my activity series and I see that zinc is above silver, which means it is more reactive, and this reaction should occur. If you have zinc being less reactive, you simply write no reaction. But that's not the case in this case. Zinc is stronger than silver or more reactive, and in that case we then have zinc, and because we know that zinc has a +2 charge, it always has a +2 charge, it means it needs to have 2 nitrates that combine with it, and it knocks the silver out, and the silver is a solid. All right, so when we add the zinc in here, we know that the net result, the after picture, so here we have the before, here we have the after, is that we do have zinc giving its electrons to the nitrate. And you'll notice that at this point it's not balanced, but I just want to do a couple of drawings where these solid pieces over here show that you have silver precipitating out. So the next step in all of this is balancing the chemical equation. So I take a look, I see that I definitely have 1 nitrate here, 2 here, so I'm going to put a 2 in front here, which changes my silver to be 2 silvers. So I can now place 2 Ags in here and 2 nitrates. This allows us this zinc to be able to bond with those 2 nitrates. So the next step, what we're going to do is called the net redox reaction. And to do the net redox reaction, I think creating what we call a complete redox reaction is a little bit easier first. So I'm going to literally draw what I see. So in this case, I have a solid piece of zinc plus, then I have 2 cations of aqueous silver plus 2 NO3 minuses. Those are aqueous. Okay. And they are going to react to make Zn plus 2, that's aqueous, plus 2 NO3 minus, that's aqueous as well. I write these apart because remember these are aqueous and I have to include that, plus 2 silver. Now the silver is by itself. That means that it actually gained those electrons that it had originally lost over there in this tug of war, because remember it won, the zinc won the anion and has given the electrons to silver. So for the net reaction, we look at what has changed. did the zinc over here change? And it did, because before it had a 0 charge, now it has a +2 charge. Did the silver change? Well, it starts with a plus charge and then it ends with no charge. So we do see a change here. How about the nitrate? We have 2 nitrates with a minus charge, 2 nitrates with a minus charge. These did not change, so these are my spectator ions. All right, so in that case, the net redox reaction is simply writing which elements actually changed and removing the spectator ions. So we're at something looks like this. The key is that you'll notice that each one has an element with no charge and one that does have a charge. So the next part is going to be writing the half reaction. So we have the oxidation half reaction. All right. And in this case, for the oxidation half reaction, for me it's easiest to remember the oil RIG acronym. So oil stands for oxidation is losing and reduction is gaining, and what they're losing and gaining are electrons. So what we're going to do is we're going to look up here, and we see that zinc here has a 0 charge. That means it has all of its electrons. And then it has a +2 charge, which means it must have lost 2 electrons. So in that case, zinc looks like it lost electrons. Silver here had a +1 charge, and now it has a 0 charge, which means that it must have at some point lost an electron, and now it got it back again. So for oxidation, just a reminder, that was losing electrons. We know that zinc lost the electrons, and the way that I want to show that is by showing an arrow, and this arrow is almost like a hand that throws out the zinc with the +2 charge plus the 2 electrons that's separated from it. See this plus sign as a separation, not as an addition. So we started off with zinc, they broke apart to be zinc +2 and 2 electrons. For the reduction half reaction, for this one here, remember it's gaining electrons. And so in this case I had 2 silver cations, and those cations each gained 1 electron, so that means a total of 2 electrons to now be 2 silvers that are solid. So make sure that your electron number here matches your electron number here, because it is the zinc that we say gave its electrons to both of the silvers. In that case, we say that the oxidizing agent, the thing that gave its caused the electrons to be given, was the silver. This silver forced the zinc to give its electrons, and the reducing agent is again the opposite thing of what was reduced, and that would be the zinc, because it is the zinc that more or less forced the silver to take those electrons.